Hello. For the past couple of years working in Unreal Engine, I've been collecting what I consider to be the best practices of how to work in it, and I made a document of this, which I figure might be good to share actually. So I'm going to make this video to talk about this stuff and to link to it. So first, it's pretty big, but I'm just going to talk through it, and you can look at the document if you want sometime, or listen to me muse on it as you see fit. So the first thing is when you're setting up Unreal Engine, there's a thing called a drive data cache. This is when it compiles shaders, it makes a copy, it compiles them into some format that's quick to read. And if you're working in a team, right, you don't all need to compile the shaders. When they change, only one person needs to, and then this drive data cache can be copied somewhere that you can access over the network. They have a documentation page about this. If you're in the office with other people, then you should set this up, and you just set it up in the default engine.ini so that it will know where to go, essentially where the drive data cache is saved on the network, and it will auto update. So that's something I really strongly suggest setting up if you're working in the office with a bunch of people. Now if you're working over the internet, don't bother because it's too slow. In that case, you should just disable the DDC stuff. Here's some stuff about how to do that. Okay, if you're going to add a project to Perforce, here's the folders you should add. You don't want to add all this other stuff. You want to add it to your ignore file. So that's what that's about. I like to use Rider, which is currently a IDE that's being worked on by JetBrains, and it's really great. It basically combines the resharper functionality that they have in Visual Studio into their own IDE, which is much faster. And it just gets away from the Visual Studio weird, like wrong working errors, wrong working when you're like coding and it's telling you things are wrong that aren't. ReSharper is much better about that, which is why I use Rider, and for now it's free. We're gonna have to see how much it is once it leaves beta, I guess. So one thing to understand about Unreal Engine is that it uses a reflection system, and the reason it uses this is because you want to be able to program in C and then have it reflected into Blueprint. There's a lot of talk about that in here. There's talk about the coding standard, which is something that's really important to follow. So their coding standard uses very specific ways of naming variables and other things, and if you're writing code, you should follow their standard so that you don't create code that's totally different looking than theirs in the engine. But also, if you use ReSharper, it will help you. It will flag things that you do that are wrong. Yeah. Another thing is you should braces on separate lines for everything. So the reason for this is that you want to be able to put a breakpoint anywhere. Okay. So if you're making a new class for Unreal Engine, you're going to always want a base class in C++ that you're deriving from, right? Like if you have a pickup, you can have many blueprints that are pickups. That's fine, but you want to be able to. You don't want to have blueprints that derive from actors so much, because then you can't get in there and disable tick as easily. There's a lot of things you can't do. So this is really important and hard to understand. When you make a constructor in Unreal Engine, like you're constructing components that are part of an actor, that kind of thing, this code gets run and kind of saved into the objects that are in the world, and it doesn't run again like all the time. It doesn't run at runtime. It's not like begin play runs at runtime. So let's say that in your constructor you want to access a variable that's in the blueprint, like how big a sphere is, for example, right? Then if you have a variable that you can set that sphere size to in the blueprint, and you set it to 20, let's say, and in the constructor you read that value, you say sphere size, and you set a sphere size to it in one of your components, you will find that it will not work. It will not update, and you'll think, well, why? Well, it's because this constructor is running before it reads the values from the blueprint. So if you have values that are changed in the blueprint, you're going to have to access them outside the constructor and begin play. So that's one thing to know. If you don't, that will really confuse you if you start trying to do that. Okay, so actors have a tick function, right? And by default it'll be enabled because they want things to work, right? They want it so that if you're trying to tick, you're not confused as to why things aren't working. So you always want to disable it if you're not using it. Components have tick most of the time. So you can also adjust the tick intervals. I often find these seem like they're more useful than they are, because when you're ticking, usually you want something to happen like rotation or movement or updating a material, the way a material looks or something, and if you throttle it like this, often it looks like crap. Okay, so when you're making your class, you're going to want to have your components created in C++, and the reason you want to do this is because if they're created in the blueprint, the only way to get access to them is to get components. So like in your C++ code, you'll have to say get root component or get sphere component, and you'll have to look through your list of components and find the one you want or tag it somehow, which is just bad practice. If it's in C++, you can always get access to it. You know, there's no having to look it up all the time, which is just much faster. So here's an example of some component there. When you have variables that you set up in your class, they should always have some value. I do think that transient values, it like zero fills them for you, so I'm not sure if it matters on them, but I just kind of blanket always put values in there. Yeah, here's me reminding you about this. Here's another thing I have found. If you try to spawn components conditionally in a constructor, if you delete components in a constructor, if you bind delegates in the constructor, bad things will happen. The editor will freak out sometimes. It'll flicker. You won't be able to select things in the description pane. So if you're going to spawn a component conditionally in general, like if it's an editor only component, there's specific ways to do that, but otherwise you should not be doing that. If you want to spawn a component conditionally, then you should do it runtime and begin play or something like that. Let's see, here's where I talk about how you can replace a component with a base, with like a child class of it. So like if you have a character as your base class and you want to use a custom character movement component, here's how to do it. Okay, so when you make a class, you can hide categories, and what this means is it hides these categories in the blueprint so that a designer or someone else can't see them and can't change them. This is great if you're trying to limit what people can change, so that they can't set things wrong. What's interesting about this though is if values have been set and then you hide them, there's just no way for people to change them or to know what they are. So you have to be careful with this one. Either hide categories immediately and don't let people work in the game, because if you go later and hide it, like let's say you hide access to tick, and somebody has turned tick on, you won't be able to see that, which will make it confusing. Okay, so there's different ways to have functions in a class. There's functions that can be called from Blueprint. There's functions that can be called from Blueprint which are pure. That just means that it's like a kind of like a const static function. You know, it doesn't change the underlying class. They've got special Blueprint getters and setters that you can use as well. That's how to use those. You can have an event which you must implement in blueprints. So I can say here's a function that has no C++, and the blueprint must implement it for it to do something. And then you can have a blueprint native event, which is a function that is a combination of C++ code and blueprint code. So they can override this in the blueprint, but it also has base C++ code. If they override it in the blueprint, though, you have to be careful because they need to call the parent functionality, or it will just not call the C++ code, and often designers and other people will forget to do that. So you have to be semi-careful with this to make sure designers know that it needs parent call functionality, or to train them for that. Let's see. If you're trying to have structures come out from C into blueprint, there's some weird stuff you have to do sometimes to get it to work. Just that. Oh, and something that's great to use is you can say that a U function is call an editor, and then this will show a button in the details panel for that actor, so that like you can play the game in simulation and then do something that you want to, like test firing a gun or test whatever. This is great, especially if you're working in VR, because then you can run the game in simulation and not put your VR headset on and then actually have things happen. So let's move on to U properties. So inside a C++ class, there's U functions, right, and normal functions, and there's U properties. And U properties, anything that's a U object will need to have a U property. So like an actor will have a U property, and transient means that it's not going to save the reference into the object. It's not going to serialize it. But this prevents garbage collection. So if you don't have U property on an actor reference, for example, if I just deleted this part and just left this part in, it's possible that this could be null pointered by the garbage collection at any time, or just become invalid, right? You can make variables that are config variables. Let's see. You can specify how a U property is editable, if it can be edited anywhere, which means in the archetype. The archetype is inside the content browser. In the world, which is in the world outliner, you can edit anywhere, right? Edit default only means you can only edit it in the archetype, which is the blueprint that you find in the content browser. And changing it here will propagate to all blueprints in the world, right? Edit fixed size is like a weird thing to do to try to limit force a size on an array. Edit instance only means it's only editable in the world outliner. So you can't edit it in the object that's the archetype. And sometimes you might want to do this for like a reference to an object that's in the level. So let's say I have a bird, and I have the bird wants to land on a platform. Well, the reference to the platform should be edit instance only, because that platform's in the world. It makes no sense to set it in the archetype, because the archetype has no access to objects in the world. And similarly to edit, you have visibility specifiers, which control where you can see things. So if you have a variable that you can't edit but you want to still be able to see, that's what these are for. And then of course there's properties for blueprint, if they can be read or written in blueprint. And then there's a bunch of meta properties which control how the U properties interact. Like you can bind widgets so that a widget can have access to the properties in C. You can clamp the minimum and maximum of values. You can set the display name, which I don't like using, because then it makes it hard to find it in C. You can set edit conditions. So this will look and make sure this boolean is true before it lets you change this, which is super nice to do for designers, because you can set up a system where they can only change what they should. You can even have 3D widgets that appear in the world for transforms and stuff. Okay, so when you have components, you can have an editor-only component, which means the component doesn't exist in the packaged version of the game. And you might have these just for designers to do something like to pick a location. And here's how to make those. So in some components, like the AI controller, it will tick. You can disable its tick if you don't need it to update the rotation of a character it's controlling. Arrows and scene components, you have to realize that if they're child components, they will be, and they're mobile, their transforms will be updated every frame. So that can be costly if you have a lot of them. It's best to either use an editor-only component and then save the relative transform and then just calculate it when you need it, so it doesn't update every frame. And in particle systems, you can use auto-manage attachment, which I have trouble with sometimes, so take that with a grain of salt. All right. So if you make a pawn, you have to use a basic shape collider as root. There's much of code written that expects to have a collider as root. If you use like a static mesh component or something else, it will complain in the engine code. So I suggest using a sphere or something as your root component. If you use a radial force component, make sure that you don't have the tick on and only tick when you want it to work. Otherwise, these are super expensive. The skeletal mesh components have a bunch of things you can change to improve their performance. They have to tick every frame to update. So if they're not currently updating, you can change that. So static mesh components, they have generate overlap events and collision on by default. Make sure that you have your static meshes set and your generate overlaps off. Oh, and then here's one of my least favorite. So a lot of designers will use timeline components thinking that they get around ticking. Like, oh, the actor is not ticking now. I don't have to do that because I'm using this timeline. Well, the timeline ticks, and it's ticking just as expensively as the actor would. So there's really, the only reason to use a timeline is if you want to use a curve and to make something happen over a curve on tick. If you're making something happen linearly or something else, you shouldn't use a timeline component. You should just do it in your own tick in C. Much cheaper to do it that way. Okay. So in C, there's things called interfaces, and basically these are functions that a class will support. So if you have a grab interface, let's say, then you could put that grab interface on any actor, and then it will have to support certain functions, and those functions can then be called. So like your pawn can cast this actor to see if or check if it supports the interface, and then call these functions, and they can silently fail if it doesn't support in Blueprint. So here's how to set those up, and here's how to set those up if you're using them in Blueprint, which is a lot different. You have to use implements, and you have to use execute if it's a Blueprint interface, which is super annoying because the way it works in C++ is very simple. I'll talk here a little bit about setting up debug systems. If you're going to set up a debug system, you got to make sure that it's not expensive and that it can be totally removed. I've seen debug systems people make where they use console variables that get polled every frame to see if they get turned on and off, which is just a bad way to do it in my opinion, because it's, there's no easy way to know a console variable's changed unless you poll for it. And if you have a lot of that happening, it's just gross. Okay. If you use Tarrays to store things, you got to be aware that if you're adding and removing from those arrays, like in a tick or on hit or in different places, it's possible that like the tick and the physics and other things can try to fire at the same time, because the game will be running multi-threaded, and like you would think these things would all be separate, but sometimes they seem to want to fire at the same time. And so like if tick removes an object and then physics gets a hit, then it can think the tick could have removed an object that the physics doesn't know about, and then you run into like array bounds issues. So what I use is these critical sections to lock the array while you're using it. So when you want to add to it, for example, you can lock it, which will prevent somebody else from doing something with it while you're adding and removing. So if you look into what the scope lock does, you'll see what I'm talking about. So here's a cool trick. Tick is is an expensive thing to do, but a lot of times you might have different functionality that you want in the tick, and sometimes it's best to actually have different tick functions so that it's easy to enable and disable them. Or even what you want to do is you have a base class that has a tick that's a different tick, so that the child classes can use the base primary tick and not be confused by it. So for example, if I'm doing something in the base class and I'm turning tick on and off, and then somebody down the line in a child class tries to use tick, and I'm disabling tick and they don't know it, they're going to be very confused by why tick is turning on and off by itself, right? So in that case, it's best to make your own tick functions in the base class that are separate so that people aren't confused by it. They can use the primary tick and not be confused as to why it's turning on and off. So here's how to do that. And you can look at how Actor implements its primary tick to see how to do this exactly. But anyway, there's how to do that. So that's most of the stuff. That's everything for engineers. So I talk a little bit about naming convention for designers. Anything you make, you should have a naming convention. You should start out knowing your naming convention, and here's a style guide that's good to use. When you're making blueprints, you should have a base class, right? You should have components created in C. You shouldn't use tick unless you have to. You shouldn't use get all actors of class unless you have to, and definitely not per frame. If you use delay nodes actually tick the blueprint to use latent actions, so that that's how they count down the time, which is expensive. You can use timers instead of delays. You should have small amounts of logic in the BP. If you have huge amounts of logic, especially like lots of math, you're going to end up having to nativize it. So you should just ask an engineer to make it. And macros are like rubber stamps. You can end up with a lot of nasty code there if you use those. Here's some information about collision, about how to make LODs, about root motion. Won't get into that stuff too much. Here's how the built-in audio works. So you can look at that if you want to understand that. And then I talk a bit about performance. And everybody's responsible for performance, okay? So you should take a look at those. Anyway, I hope sharing this document helps some people who are trying to learn. And if you have any questions, just post them in the video. And I'm going to try to keep this updated as I learn new things. Thanks.